My name is Johan from PowerOptimal, and today I'm going to show you the test procedure and quality control on the Elon 100 as it comes from the factory. Firstly, as these 9 terminals carry up to 80 amps, it's important to ensure that the screws are tightened properly. I'm not going to show you online. Secondly, there are 2 transistors that use the case of the chassis as a heatsink, and it's important to ensure that they are tightened properly as well. Then we have 3 transistors that must not touch the chassis, and it's important to ensure that there is a gap between the transistors and the chassis. There are 5 electrolytic capacitors on the main PC board, and one should ensure that the markings on the capacitor, the polarity, is in accordance with the printed circuit. White to white. 1, 2, 3, 4, 5. On the relay board, that can be pulled up, and the 3 diodes should correspond, the cathodes should correspond to the cathode markings on the printed circuit board. And again, the capacitor polarity, the white should correspond to the white on the printed circuit board to ensure correct polarity. It's important to test all the spade connectors for integrity, see that they're gripping properly. And finally, it's an idea to check the 9 wires from the connector block against a known working sample that they are wired to the correct points on the printed circuits. Then 2 bridging connectors should be connected, link 2 and link 1 should be connected to P and P as indicated on the printed circuit, and also the transformer value should be 110 connected to the input side, which is nearest to the side of the chassis. Finally, there are 1, 2, 3, 4, 5, 6, 7, 8 resistors, 5-watt resistors. It's important that they should be compared to a known unit sample, that the values are correct. On any units returned from the field, the very first thing is to check if there are any components that showed overheating burns or any wires, and then if everything mechanically looks fine, exactly the same procedure as the quality control procedure that is followed to start the fault finding process. Electrical connections to the Elon 100 are according to the installation instructions. In this particular case, just to speed up, I've made a fixed harness that plugs directly into the Elon's connections, just to speed matters up. With the normal remote control cable to the RS connector, it goes to the controller with 4 positions. The first position is designed to measure the DC 12 volt on the actual Elon. The second position is exactly the same as a standard remote control set to solar, as well as facilitating a function where the 5-minute wait period to introduce mains is taken to about 5 seconds. The next position is exactly the same as the standard remote control in the solar only position, and the final position is exactly the same as the standard remote control in the mains only position. Here we've got a multimeter that will measure the voltages mentioned. The final position will also show the DC voltage the 5-volt DC voltage on the processor. Under the bench, I've got a variac, which I can vary from 0 to 500 volts to ensure that the power supply can stand 500 volts. This side of the harness connects to this, to the solar input, positive, negative. The next two wires will go to an element, in this case through a large resistor to an LED. Next two connectors will go to our thermostat, which is simulated here by a switch, and the three connections, neutral, line, and earth, for the 230 volts IC input. In order to verify that the Elon 100 conforms to the specifications, we had a setup that consists of about a 120 volt power supply, voltage power supply, in series with about 20 ohms to simulate the solar panel. We have an oscilloscope to look at waveforms and voltages, and we have a simulated Elon remote control, which has one feature that saves time, as an Elon takes 5 minutes to respond to mains. This will take a few seconds to respond to the mains in order to make testing more efficient. In order to confirm DC internal voltages, at about 180 volts AC, we should measure between 11 and 12 volts DC on the 12 volt supply. That should remain stable right up to 500 volts. Turning it back to about 195 volts. And we check the 5 volts DC, which should be about 4.4 in that order, because it's measured after the diode. Go back to the first position, and we can now measure, we can now program the unit. The 4.4 volts is important, as if there's a failure there and the voltage is too high, we could damage your programming device. You program the Elon. It's done by plugging the Picket 3 onto the programming port. Lights indicate activity, and when the blue light starts flashing again, the program is complete. We can now supply solar panel voltage and create a DC short between one of the supply lines of the PV and an earth. The lights indicate, the rapid flashing indicates that that was acknowledged. Going to the solar only position, we can now supply DC solar voltage to the Elon, which is indicated by the green line. We use 10 times probes, so 130 volts DC on the Elon. The thermostat can be closed. The amount of DC was checked by the short green pulse, and the longer ones following indicated that the solar panels were actually shorted out during the switching transition. The blue light indicates that there's power going to the element. Blue and the green coincide to show exactly the same voltage as the solar voltage going to the element. We can now switch to mains only. Mains is indicated, and overvoltage should occur at about 280 volts, so we'll take it to about 285 volts. Mains is reset and no power going to the element. At about 260, it should restore within about 10 seconds. Reset it to about 255. There's no indication at the moment. Mains is back and the red light indicates by flashing that the element is being knitted with mains power. We can now take the voltage down to about 160 volts, and it should still not trip on under voltage. At about 140, it should trip this at about 4 or 5 seconds. And we can now switch back to solar. Test is done again, and the solar voltage is applied to the element, indicated by the blue light again. The green light flashing indicates solar power being delivered to the element. About 10 seconds or so, we can remove the power, the solar power, to the Elon, and we should hear a relay clicking, indicating that the unit is restored to the cold start routine for the next session. There's the tip. Once testing has been completed, ensure that the relay board is snugly against the back of the chassis. The cable tie can be tightened, and excess can be cut off.